Hey, it's Mr. Alexander again, and we're going to finish up these notes here on finding inverses. So far we've talked about how to find the inverses on the table, how to do it graphically. Now we're going to talk about how to find an inverse algebraically. And the process is very simple. All you need to do is exchange the x and the y, and then solve for y. So that's what we're going to do here. I've got this function, 2x plus 2, f of x equals 2x plus 2. Go ahead and change that f of x into a y, and then exchange the x and the y. X equals 2y plus 2. Now we're going to solve for y. I'm going to subtract 2. X minus 2 equals 2y. Then I'm going to divide everything by 2. And it's going to leave me with y equals 1/2 x minus 1. At this point, we're supposed to stop and say, is this thing a function? Well, this is a linear function. It's in slope-intercept form. So yeah, that thing's a function. And if it is a function, then we need to write it in function notation. So that's f negative 1 to the negative first power x, or the way we read that is f inverse x equals 1/2 x minus 1. That's the inverse function. Not all inverses are functions, but in this case, the inverse is a function. All right, over here, change the f of x to a y, and then exchange the x and the y. And now we're trying to get this y by itself. I want you to get rid of this square by taking the square root of both sides. When I take the square root over here, it cancels out that square. Now remember, whenever you take the square root of something, you have to remember to write the positive and negative root of x. Now we can get this y by itself by adding 1 to both sides. Y equals positive and negative root x plus 1. That's the inverse. Question is it a function? The answer is no. The dead giveaway is right here. Anytime you have to write positive or negative anything, it's not a function. So I'm going to write not a function. But it could be if we do something that we talked about in the last video, which is restricting the domain. So this is not a function unless the domain of the original function f of x is restricted to. Now here's the tricky part, figuring out what you need to restrict it to. I've just graphed x minus 1 squared right here, and we want to pick the value of x that splits this thing in half. Well, that vertex is right there at x equals 1. So if I was going to graph the axis of symmetry, I'd graph x equals 1. Now, the way I'm going to split this in half is I'm either going to say, okay, this thing can go from negative infinity to 1, or from 1 to positive infinity. So I can either restrict that domain from negative infinity to 1, or from 1 to positive infinity, like that. So it's not a function unless I restrict the domain of the original function. Now let's do a few more of these. So I've got, let's change that to a y. Exchange the x and the y. X equals y plus 3 divided by negative 3. And let's multiply both sides by negative 3. That'll give me negative 3x equals y plus 3. And then I'm going to subtract 3 from both sides to get y equals negative 3x minus 3. Well, this is again is a linear in slope-intercept form. So yeah, that's a function. And since it's a function, I'm going to write it in function notation. F inverse of x is negative 3x minus 3. Let's look at D here. F of x equals the cube root of x minus 7. If you're wondering where to find that cube root on the calculator, it's pretty simple to find. It's under math 4, cube root of x. I just want to graph this thing really quick to see it. I want to convince you that the cube root is a function, so I'm going to do math 4 x minus 7. and hit graph, and you can see that that cube root, it passes the vertical line test. So yeah, this thing is a function, which is why I have it in function notation. So I'm going to change that function symbol into a y, and then I'm going to exchange the x's and y's. Cube root of y minus 7. The first thing I want to do is get rid of that cube root. Now, the inverse of a cube root is simply a cube. So I'm going to cube both sides, which gives me x cubed equals the cube root and the cube will cancel each other out, y minus 7. Now I'm going to add 7 to both sides, so y equals x cubed plus 7. Is that a function? Yeah, sure it is. It's a cubic function. So I'm going to write it in function notation. F inverse of x equals cube root, or x cubed plus 7. All right, let's keep rolling along here. F of x equals 3x minus 6. Let's change that to a y and exchange the x's and y's. Add 6 to both sides. X plus 6 equals 3y. And then divide everything by 3. Y equals x divided by 3 plus 6 divided by 3. Is that a function? Yeah, that's a function. That's a linear function. So I'm going to rewrite it in function notation. F inverse of x equals 1/3 x plus 6 divided by 3 is just 2. So there's your inverse function right there. How about g of x equals 2x squared plus 5? Well, let's change that to a y and make it x equals 2y squared plus 5. I'm going to go ahead and start by subtracting the 5. X minus 5 equals 2y squared. Now you might be inclined to get rid of the square by taking the square root of both sides, but you don't want to do that yet, because when you take the square root of this, you'd be taking the square root of 2. And that's going to complicate things, so you actually want to divide both sides by 2 first. X minus 2 minus 5 over 2 equals y squared. And now you can go ahead and take that square root. Y equals the square root of 1/2 x minus 5/2 is just 2.5. But don't forget, anytime you take a square root, you've got the positive and negative square root in there. Is that a function? This one is not a function. The dead giveaway is the plus and minus right there. So I'm going to write, it's not a function unless the domain of g of x is restricted to, now here's the tricky part, we've got to figure out what's restricted to. And to do that, I'm going to type in the original function, 2x squared plus 5, hit the graph button. What's the value of x that would split this thing right in half? Well, that's just x equals 0. So I can either take the left half or the right half. The left half would be from negative infinity to 0. The right half would be from 0 to infinity. Which one you take? Doesn't matter. So I could restrict it to negative infinity to 0 or 0 to positive infinity. And that's the only way to make this thing, make the inverse a function. All right, let's talk about, first off, make this a 5. F of x equals the 5th root of x minus 4. Change it to a y. Exchange the x's and y's. X equals the 5th root of y minus 4. Go ahead and add 4 to both sides to get x plus 4 equals the 5th root of y. How do you undo 5th root? Well, you go ahead and raise everything to the 5th power. So I'm going to have y equals, because the 5th root and the 5th power cancel each other out, y equals x plus 4 to the 5th power. Now you might be looking at that wondering if it's a function or not, so I'm going to go ahead and graph it. X plus 4 to the 5th power. It looks an awful lot like a cubic. It's not a cubic, it's to the 5th power, but it looks like a cubic. and it is indeed a function. So I'll say, yeah, it's a function. And so I'll write it in function notation. F inverse of x equals x plus 4 to the 5th power. Alright, got one left, and then this video will be over. H of x is x plus 3 cubed minus 7. So let's flip the x's and y's. X equals y plus 3 cubed minus 7. I'm going to add 7 to both sides. X plus 7 equals y plus 3 cubed. How do you get rid of that cube there? Well, you take the cube root of both sides. So the cube root of x plus 7 equals y plus 3. Notice that I didn't write a plus minus in front here. You only have to do this plus minus thing when it's a square root, a 4th root, a 6th root, an 8th root, when it's an even root. This has an implied 2 right there. If it's an odd root, like 3, 5, 7, 9, 11, then you don't have to write the plus minus on there, for reasons that we will talk about in the next lesson. So hold on to your hats. 2 days we'll talk about why there's not a plus minus in front of there. The last step, though, is to go ahead and do y equals the cube root of x plus 7 minus 3. Well, that is a function. We can graph that. If you don't believe me, I will graph it. The cube root, that's math 4, of x plus 7 minus 3, graph it. Sure enough, that's a function. So I'll write it in function notation. Oops, it should be h inverse of x equals the cube root of x plus 7 minus 3. And that's it. That's how you find inverses. Thanks for watching.